There was a time when the great southern landmass wasn't just covered in ice glaciers and penguins. It was filled with forests, flowers, and all sorts of animal species. It even had a completely different climate. So, how did we end up here? Let's take a brief trip in time and find out what happened. Around 550 to 180 million years ago, Antarctica was part of a supercontinent called Gondwana. It was connected to South America, Australia, Africa, the Arabian Peninsula, and the Indian subcontinent. The breakup started in the Jurassic period. They just couldn't get along. Around 180 million years ago, Antarctica began moving to the bottom of the globe. According to fossil records found below the ice caps, the icy continent was once a very hot place. In fact, it got so warm that the climate became tropical, like the one we see today around the equator. About a half-mile below the seabed at Wilkes Land in eastern Antarctica, scientists have made a great discovery. They found fossils containing pollen from plants that only flourish in the tropical environments we see today. They also found the same pollen going back millions of years close to the Arctic Circle, but I'll get into those in a bit. Now, we all know that tropical vegetation can't stand cold weather, so it's believed that the eastern part of Antarctica didn't have frosty winters. The average winter temperatures were similar to the ones in South America. As it turns out, this is a repeating pattern. Everyone previously thought that Antarctica reached high temperatures for the first time just before the Eocene period, approximately 56 million years ago. But after research, paleontologists found more fossilized plants that go all the way back to the Devonian period, somewhere around 419 to 358 million years ago. What's a couple of million here or there? Now, around 100 million years back, the Earth went through a massive long-lasting heat wave, scientifically known as the Paleocene-Eocene thermal maximum. During that time, the global average temperature increased that resulted in changes to vegetation. Antarctica was filled with all sorts of trees, plants, and flowers. Even palm trees made an appearance, alongside relatives of today's tropical baobab trees. The climate of the continent became flexible. During the Eocene period, Antarctica supported a variety of ecosystems. At high elevations and further inland, several plants present in the temperate rainforests were found. One of them was the southern beech. Fossils that were found on the continent preserved the biology and chemistry of the flora. That helped researchers understand how some of the plants survived the mass extinction while others didn't. However, vegetation wasn't the only thing spreading all around the icy continent. On Seymour Island, which is around the tip of the Graham Land on the Antarctic Peninsula, scientists discovered brood balls, a unique structure that dung beetles lay their eggs in. That means these little guys had to be feeding on something. Later, scientists found remains and isolated teeth, showing that several mammals lived in the area. A few of them all belonged to the same type of ancient marsupials, like the modern Colo-Colo opossum. It was a tiny insect feeder native to South America. Another type of marsupial found was the bibidiba, also pronounced Anarctodolops. It was the first recorded fossil, discovered in 1984. Some described it as a critter resembling an opossum. For those of you keeping score, a critter is a close relative of the varmint. Then, a toe bone was found, making scientists believe that a group of mammals called Xenarthra also lived in the continent. This family included the sloths we have today. These guys first evolved in South America, but so did the descendants of a hoofed mammal found in Antarctica called Nothiolophos. These creatures fed on tiny tree branches and saplings. Scientists discovered their diet by analyzing the animal's teeth, which were relatively small in size. When they investigated the fossils further, they found that there were two types of Nothiolophos, the Nothiolophos arquenotiensis and the Nothiolophos rigeroi. Hope you were paying attention. That's the last time I'm saying those Latin names. Sheesh! The first one weighed a little less than 510 pounds, maybe 508, while the other one was only 130 pounds. Because of their size difference, it's believed that both mammals could be specialists. That means they fed on different types of plants to avoid competing for food. Another hoofed creature that entered West Antarctica from South America during the early Eocene period was the Antarctodon. It belonged to an unusual group of now extinct mammals. It lived in what we now know as Seymour Island. Only fossilized teeth of these guys were found, but somewhat complete skeletons of other mammals in this family show that they resembled tapirs. Some of these species also had sharp canine teeth. They were able to feed on both nuts and soft plants. It's speculated that a few of them could be semi-aquatic, like otters and beavers. But the fossil record in Antarctica is troubling. It isn't as complete as those in other continents. Some of the bones found are either fragmented or isolated. The good thing is, the yet-to-be-discovered fossils might be well preserved under the ice glaciers. The existence of these creatures during the Eocene period shows that Antarctica was a great habitat for land mammals. So how did the tropical greenery become a frozen, unwelcoming environment? Real estate prices? Scientists are still trying to understand the time scale of when things change. Since those animals coexisted, changes began happening slowly. They believe that approximately 56 million years ago, South America began separating itself. 16 million years later, Australia and Antarctica began drifting apart in the sea. Between 36 to 23 million years back, another natural channel emerged, the Drake Passage. That also proves that the continental drift happened gradually. Antarctica was a land bridge between Australia and South America. As it broke apart from South America and later from Australia, it started moving south. That made room for a new force to emerge in the Southern Ocean called the Antarctic Circumpolar Current. The ACC flows clockwise from the west to the east. It's considered the most powerful current in the world to this day. It carries between 5.8 to 6.4 billion cubic feet of water every second. Since there's no land to block the current, and because of the way it flows, it prevents warm waters from reaching Antarctica. The ACC also brings cold water from the seabed of the ocean to the surface. That resulted in a drop of temperatures on the isolated continent. There's insufficient evidence to show a connection between the rise of ice glaciers in ancient Antarctica and the ACC. But climatologists believe that the current is 41 to 23 million years old. Towards the end of the Eocene and the beginning of the Oligocene period, global cooling started taking place. The temperatures dropped at high latitudes in both the Arctic Circle and Antarctica. The carbon dioxide levels in the Earth's atmosphere had dropped significantly. According to Professor Stephen Picard, approximately 55 million years ago, there were more than 1,000 parts per million of carbon dioxide in the Earth's atmosphere. During that time, the high temperatures on Earth melted all of its ice caps. That caused the sea levels to rise about 200 feet higher than they are today. Scientists were trying to figure out why our atmosphere went through such unpredictable fluctuations in CO2. Some theorists suggest that during certain periods, the tectonic plates moved and triggered carbonate-rich rocks and other remains to release carbon dioxide. This caused the air to heat up, and the ice caps melted. But then, the cycle continued. 34 million years ago, the levels dropped from 1,000 to 760 parts per million. 14 million years later, they dropped below 300 parts per million. The CO2 was absorbed through natural processes, which contributed to the global cooling effect. Over geological times, atmospheric pressures and carbon dioxide levels were linked. When the first one rises, the second one follows. The ice glaciers in Antarctica began to form from 36.5 million years ago and onward. They started spreading across the continent, and vegetation began to disappear. But here's what's interesting. According to a fossil study that examined plant samples from the area, scientists found that the variety of plants decreased by 47%. This started at the end of the Paleocene epoch, 58 million years back, until the mid-Eocene period, 40 million years ago. Tropical plants were slowly replaced by temperate forests filled with southern beech trees. The later ones disappeared 2.5 million years ago. Today, Antarctica is a deserted continent. The closest thing to flora there is moss, algae, and lichen. Well, Antarctica became an isolated landmass without much life. Australia and South America thrived. One thing the three had in common were the marsupials. In Australia, the marsupials multiplied. Some of them were kangaroos, the now extinct thylacine, and wallabies. Fossil records show that kangaroos date 20 million years back, but they weren't hopping at first, they just clung to tree branches. New DNA evidence shows that the oldest marsupial lived in South America 70 to 80 million years ago. It's believed that they migrated from South America all the way to Antarctica and crossed over to Australia while they were still connected. That's how similarities in species exist in both continents. But of course, they evolved differently in their new habitats. So, I don't know about you, but, other than you're a smart, inquisitive person who loves to learn new things here on the bright side, but regarding planning for the future, well, I sometimes have great difficulty forecasting where I'll end up at the end of the day, let alone next month or even year. A scientist named Niels Bohr once said, "Prediction is very difficult, especially about the future." It turns out that there are some trend-based prophecies for the far-off distant future. So, check out these amazing things that could become our reality by 2100. Let's begin with the years 2020 to 2029. India has become the most populated country in the world by the year 2022. China has fallen to the second position on this list. People have completely broken language barriers. New technologies have made instant translation nothing out of the ordinary, and voila! Your smartphone speaks Indonesian on your behalf. So now you can butt dial anyone in the world and they'll understand who dialed the wrong number. By 2020, they have finished construction of the tallest structure in the world. The top of Jeddah Tower in Saudi Arabia is towering above the planet at a height of 3,281 feet. Scrolls, which are in fact groundbreaking screens that you can roll up, have replaced good old solid tablets. The ultra-thin digital displays can reproduce video, images, and text and let you browse the internet. Your car is completely integrated into the universal traffic system. Not only does it communicate with traffic lights to improve safety at intersections, but it also interacts with other cars, which prevents accidents. Besides, your car has learned to search for the gas stations with the best discounts. Oh, and it handles all the payments as well. And if your car breaks down, you can easily print the necessary replacement part with the help of a 3D printer. Passwords have become obsolete. Face recognition, voice prints, retinal scans, and even heartbeats will replace passwords entirely. More than 5 billion people use the internet worldwide. That's equal to the whole Earth's population back in 1987. Self-cleaning buildings have appeared, which also fight smog and air pollution. They're coated with titanium dioxide that, when heated by sunlight, releases free radicals and breaks the grime down. Then everything gets washed away in the rain. By 2020 to 2021, the first space hotel has opened its doors for the first visitors. No wait, that's a bad idea. They all get sucked out into the vacuum. How about we open airlocks for them instead? Either way, to see our planet from space, you still have to fork over about $9.5 million for a 12-day trip. The year 2025 and the world's population has grown up to 8 billion people. I feel bad for introverts. No room to hide anymore. At least now you don't have to wash your clothes anymore. The same titanium dioxide coating that protects buildings also helps cotton to get rid of stains on your shirts. On top of that, it wipes out all the bacteria that produce unpleasant smells. All you need to do is spend a few minutes in the sun. By 2028, it's become impossible to live in Venice, Italy. While the town is not entirely underwater, the water level is so high that people have deserted their houses. So, if you haven't visited Venice yet, hurry up! Years 2030 to 2060. By 2030, the Arctic ice sheet has significantly decreased in size. What's more, all the ice in the Arctic Ocean melts during the summer. And by 2037, all the Arctic sea ice might have disappeared altogether. People have digitized all the books that have ever been written, and isn't it super convenient? On the other hand, To carry along the Library of Humanity, you'll need to have 124 3-terabyte drives. In 2033, a manned mission sets off for Mars. As for the whole space exploration program, also called the Aurora program, it's going to concentrate on exploring the Moon, Mars, and nearby asteroids. By 2045, the over 60-year-olds have outnumbered teenagers and young people for the first time in history, which has created some problems with employment. But don't worry, hospitals, for instance, have solved this issue with the help of robots as staff members. Supersonic jets running on fuel made of a special air mixture have appeared. That's why these days you need 2 hours at most to get from London to New York. Not only your car, but your home as well has become completely connected. Special sensors inform you which part of your garden you should fertilize. Your carpets detect intruders and call for help if something happens and you fall. Your thermostat knows your temperature preferences and adjusts the climate in the room you enter. Tiny supercomputers that are no bigger than a sugar cube have seen the light of day. With the appearance of nanoparticle-infused liquid, there's no need for all the wires. The only problem will be finding the gadget in your pocket. If your usual order is a cup of decaf coffee, you're in for a pleasant surprise. By 2030, farmers have started to grow caffeine-free coffee beans. There are more than 9 billion people on the planet, and 7 out of 10 live in cities and towns. To produce food for all of them, farm scrapers have been built. These vertical farms feed urban areas by growing pesticide-free vegetables, fruit, and crops all year round. Years 2061 to 2100. Good news! By 2075, the ozone layer has healed itself entirely. No more holes that let in dangerous ultraviolet light that causes serious diseases. On the other hand, by the end of the 21st century, almost 83% of the Amazon rainforest has disappeared due to climate change and consequent droughts. People have literally heated up the world. There are tiny sensors all over your body. Thanks to them, doctors can monitor your vitals round the clock. Spinal cord implants that are capable of reversing paralysis are now available. Chips in your brain help you get new information while you're asleep. Plus, if you want to lose weight, you can get a stomach chip which will monitor your diet. Due to the wide use of artificial implants, such as bionic eyes, synthetic blood, or ears with enhanced hearing, a lot of humans have become more non-biological than biological. People have started the construction of a transatlantic tunnel. Theoretically, with the help of a magnetic levitation train that can reach the speed of 4,000 miles per hour, you'll be able to get from America to Europe in less than an hour. Lots of Winter Olympic sites have become unsuitable for holding the event. There are no regular snowfalls, so many winter sports have moved indoors. By 2100, all the world has become connected with the help of hypersonic tube trains. They incorporate the features of maglev trains and pneumatic tubes. These vac trains levitate inside closed tubes, moving forward with the help of magnetic fields. One of the fastest developing regions in the world is West Antarctica. After the ice has melted in some regions of this continent, the land has become suitable for building huge cities with high-rise buildings. Antarctica's population has grown up to several million people. Many languages have died out, and the total number has dropped from about 7,000 to less than half of this figure. Despite numerous attempts to prevent climate change, people haven't managed to save most lowland regions, and as the sea level has risen by almost 6.5 feet by 2090, millions of people have been forced to relocate. Many countries have spent trillions of dollars on evacuating and relocating their citizens, as well as coastal defenses. On the bright side, the average person works less than 20 hours per week. I'll bet people in the future are immensely grateful to AI for changing the nature of work. Jobs have become more intellectual and creative. Our lovely climate, from tropical to polar, arid to damp, and all that just right temperate in between. It comes in all flavors and has been constantly changing since the very birth of our planet Earth. This must be some sort of mistake. I booked a trip back in time, not to another planet. Oh, this is what the Earth looked like 4.5 billion years ago. So unrecognizable. It's super hot and molten all over. Just look, entire oceans of magma. It'll take almost 1 billion years for our planet to take its solid form. Ah, what was that? A meteorite? Yeah, they were frequent visitors to Earth back then. That's why it couldn't get a chance to solidify. You can also thank a huge Mars-sized object for crashing into our planet and forming the Moon at this time. Why is it so hard to breathe? Ah, there's no oxygen in the atmosphere yet. It's mostly just helium and hydrogen during these early Earth days. No wonder I see no wildlife whatsoever. Does anyone have an umbrella I could borrow? I feel like all this rain would be enough to fill an ocean. Oh yeah, it did just that 3.8 billion years ago. The rain came from those clouds over there, the first ones in the history of Earth. They formed because the planet eventually began to cool down, allowing water to go from a gas to a liquid state. I never thought I'd say this, but I'm excited to see all these bacteria here. It's a sign the Earth is becoming a suitable place for living creatures. But I still can't breathe normally because the atmosphere is extremely toxic 3.5 million years back. At least these early microorganisms will fill the atmosphere with oxygen over the next 2 billion years. Hey, it's getting colder. Around 2.5 billion years ago, the HURONIAN glaciation starts. As oxygen fills the atmosphere and replaces methane, it can't trap heat as well. It's the oldest ice age we know of, and the Earth's surface is frozen solid. There's also mass extinction of bacteria and single-celled organisms that can't live under the new conditions. 2 billion years ago, the ozone layer starts to form. It not only protects the planet from the sun's harmful radiation, it also warms this planet up a bit. The Earth explodes with life, which moves from the oceans to the land over the next billion years. Trilobites, crustaceans, and eventually… Dinosaurs! Run! Quick, let's hide in that cave over there. About 200 million years ago, these giant reptiles appear, and they'll rule the planet for the next 175 million years. The climate during their rule is pretty hot and humid. There are no polar caps at this time. They've melted, which causes a rise in global sea levels. From 100 to 65 million years ago, the planet goes through so many changes. The single landmass is breaking apart into the continents we have today. The climate is becoming more regional and seasonal, cold at the poles and warmer toward the equator. The biggest change, though, has to be the end of the dinosaurs. Poor guys. 55 million years ago, something similar to today's global warming trend takes place. Carbon dioxide builds up in the atmosphere, and the global temperature reaches to a toasty 73 degrees Fahrenheit. I must say, the Earth is such a beautiful place with no trash and plastic and neon signs. Hey, what's that fern doing out there? Ah, the famous fern that cooled the planet, Azolla. 49 million years ago, it starts flourishing in the Arctic, munching on the planet-warming greenhouse gas carbon dioxide. For the next 2 million years, life on Earth is like a roller coaster, with temperatures going up into a hothouse and down into an ice age. By the way, I have a question for you. Would you rather spend 1 year in a super hot or super cold environment? Let me know down in the comments. Anyway, I'm gonna fast forward a bit through time. Let's turn on the boosters. Woo! Don't crash into that rock! Whoa, was that a mammoth? Faster, let's get out of here. Ah, made it to the Ice Age that started 2.5 million years ago. The average temperature is about 12 degrees colder than it is today. In these conditions, snow doesn't melt during what is now summer in the northern parts of the world. Ice covers present-day Europe, Asia, North and South America, and of course, Antarctica. There are even glaciers on mountaintops in Hawaii and Africa. And what's that beast over there? Oh, that's a giant short-faced bear. They thrive just beyond the ice-covered areas. Can I borrow that umbrella again? Thanks. I guess I'll need it for a while. In the period between 120,000 and 30,000 years ago, It rains cats and dogs, and maybe mammoths too. Even the Sahara becomes wet and fertile. Look at all those lakes, swamps, and rivers. Yep, it's another warming. And where are all these people going? By the way, I'm excited to finally meet some Homo sapiens. They must know something I don't yet. Hey buddy, what's going on? Oh, it's getting colder again? I see. They're moving in search of a better and warmer life. Around 26,000 years ago, the ice starts to spread yet again. It's dubbed the last glacial maximum. Another 12,000 years go by, and I no longer need a sweater. Temperatures in the northern Atlantic region rise to pretty much today's levels. It's a warm and humid period before the start of the Holocene. Now, the Holocene is the name of the current geological epoch. It started 11,700 years ago. What's that dripping on my head? Oh yeah, ice sheets in North America and Europe start melting at this time. Without that many glaciers, the Earth starts looking completely different. Forests replace tundra in Europe, so don't be surprised to see all these cute forest animals here. Let's see what's happening in Africa. Between 7,500 and 3,500 BCE, the latest African humid period ends. What was recently a lush oasis in the Sahara now becomes the arid desert we know today. And look, those guys over there must be picking land for the first Egyptian pyramid. I wonder what's going on in America at this point. In 3000 BCE, the western part of the present US is going through some big changes. It's a wet and colder period that helps fill the lakes of the Great Basin and refill the springs that had previously dried out. I think I can see something in the air. Ash? Uh-oh, it's a volcanic eruption. Mount Vesuvius explodes, and some other major volcanoes wake up at this time as well. It means I've just found myself in the cold epoch of the Bronze Age. Temperatures are particularly low in the North Atlantic region from 1800 to 1500 BCE. It doesn't get any warmer in the Iron Age cold epoch, lasting from 900 to 300 BCE. Hey, they called it cold for a reason. Ah, finally. My thermometer is showing that it's warming up again. Between 250 BCE and 400 CE, the North Atlantic and Europe enjoy unusually warm weather. One ancient historian even wrote that date trees start growing in Greece at this time. Anyway, back on track, I can sense something in the air. Ash again? And is that lava? Run! In the year 535, another volcanic eruption, this time in the tropics, causes another crazy temperature drop. It's the most severe one the Northern Hemisphere has seen in the last 2,000 years. But then again, guess what? It's getting warm again. Man, this climate just can't make up its mind. The sun gets stronger and more active, the volcanoes decide to take an extended nap, and ocean currents change direction a bit. All this starts the medieval warm period that lasts in the North Atlantic region between 950 and 1250 CE. One thing I realized on this climatic journey, you should never keep your sweater too far away. I'll definitely need it to survive the Little Ice Age that starts somewhere around 1300 and goes until 1850. It's called Little because it isn't exactly as extreme as the previous ones. But still, some intervals of it are pretty tough. A lot of things happened in the world since 1850, but in climate history, it's all been pretty stable so far. But I'm sure you've heard that it's going on the warmer end. Do you remember how beautiful and huge glaciers used to look? Well, the temperatures are rising, especially in the Arctic. The polar caps are shrinking, deserts are expanding, sea levels are rising, and all of this is happening because of greenhouse gases. I hope we'll figure out a way to solve this problem. I don't know if I can take another really hot period. Whew! You know, there's one unique place on our planet where there are no hordes of tourists, no traffic jams, and no high-rise buildings. This place is one of the hardest to reach, and it's almost impossible to survive there if you're unprepared. Right, I'm talking about my backyard. Crazy! Oh yeah, and also there's Antarctica, the home of bizarre findings and even more mysterious phenomena. One of them is the deafening roar that's heard from the frozen terrain every night, accompanied by enigmatic ice quakes. Something very strange happens in the coldest place on Earth, and this something makes the frozen valleys of Antarctica shake up to several hundred times a night. But while this experience might terrify even the most experienced observer, all the strangeness has a perfectly scientific explanation. Recently, researchers from the University of Chicago have been studying the coldest continent with the help of a vast network of seismometers spread all over the Antarctic ice sheet. That's when they first observed a curious thing. Every night, the ice came alive, causing thousands of tiny, 1-second-long ice quakes. These ice quakes happen even in the most remote locations, where there hadn't been any seismic activity before. It puzzled the scientists to no end. After all, while ice quakes weren't something out of the ordinary, the fact that they happened at night was anomalous. Which here means deviating from what is standard, normal, or accepted. Another addition to your growing vocabulary courtesy of the bright side. But eventually, the researchers found the answer to this enigma. And just like many other worrying natural processes nowadays, the nightly ice quakes seem to relate to the recent climate changes. In particular, with melting polar ice caps. Warmer temperatures leave us with ponds of melted water with a layer of ice on top. When it gets colder at night, the ice layer contracts and the water underneath this ice starts to freeze. As a result of this process, the volume of the water becomes bigger. The pressure accumulates until, at one moment, wham bam, the ice cover breaks with a loud snap, and there it is, a tiny ice quake. This process would resemble a volcano eruption, but for the small scale and ice instead of lava. Scientists think that the ice quakes that keep shaking glaciers are yet another example of how much stress our planet experiences because of the changing climate. But if you're still not convinced, how about this? In 2014, scientists who were monitoring the Ross Ice Shelf in West Antarctica recorded a blood-curdling acoustic oddity. With the help of super-sensitive seismic sensors, and by the way, all those S sounds strung together are called alliteration. Oops, off the tracks again. Anyway, they managed to capture a soundscape that could belong to any haunted house soundtrack. This spooky melody was just a reflection of how Antarctica's ice was changing under the influence of global warming. The sound was coming from seismic waves that were rippling through the ice shelf. The top several feet of loose ice and snow, called firn, are extremely vulnerable to what's happening on the surface, be it changes in temperature or wind direction. For example, the researchers noticed that the ice tune was different after storms blew through, but every time afterward, the melody returned to normal. That is, until a warm spell hit in January 2016. That's when the pitch of the ice tune dropped. The reason for that was the melting of top layers of ice and snow, which slowed down seismic waves coming through the firn. But that wasn't the worst about the unusual warm January weather. Researchers were shocked to find out that even after the temperatures had returned to the average January norm, and we can only guess that this norm is nothing short of freezing, the pitch of the tune didn't become higher again. It could only mean one thing: the changes in the firn were permanent, or at least semi-permanent. Is it a big deal? I'm afraid so. When the firn melts, it not only makes the ice shelf unstable, but also speeds up the streaming of ice into the ocean. This problem is especially acute in West Antarctica, where warm ocean currents undercut floating ice shelves. If the worst happens, this region can cause sea levels to rise by more than 10 feet. So, even without the accompanying horror movie soundtrack, the processes occurring in Antarctica are already frightening enough. However, ice quakes and mysterious tunes aren't the only puzzles scientists have managed to crack. It started in the early 1970s, when satellites were just beginning to take photos of Earth. In one of the images, researchers spotted a huge enigmatic hole piercing one of the seasonal ice packs floating in the Lazarev Sea in Antarctica. When summer came, the gap disappeared, leaving more questions than answers, only to reappear almost a half a century later in 2017. Then, in winter, when ice is supposed to be at its thickest, a monstrous 3,700 square mile hole unexpectedly showed up at the very same ice pack. And as if that wasn't enough, just 2 months after that, the gap grew a staggering 740% larger. When it got warmer, the hole vanished without a trace once again. But this time, scientists had an idea of what this phenomenon might be. It turned out that such short-lasting gaps could be scars left by cyclonic storms. And indeed, in September 2017, cold and warm air masses collided over the South Pole. It caused powerful winds, swirling inward and reaching a speed of 72 miles per hour, as well as towering 52-foot-tall waves. These forces tossed the ice pack around, eventually creating a bizarre-looking hole. But scientists are sure that, despite how threatening and dramatic such a gap may look, it often plays a crucial role for wildlife survival. Connecting the ocean and the sky, it creates a habitat for phytoplankton and convenient pathways for animals like penguins and seals. On the other hand, huge gaps in ice packs indicate climate changes and can influence the climate themselves, not only regionally, but globally as well. For one, they change the ocean's movements. What's more, they create, so to say, windows through which tons of energy leak from the ocean into the atmosphere, adding to global warming. And that's the most disturbing thing about ice pack gaps. The warmer the climate on Earth becomes, the more cyclones rage at the Earth's poles. And therefore, more and more climate-changing gaps appear in ice packs. Looks like a vicious cycle to me. This problem becomes even more urgent as soon as you get to know that under Antarctica's ice cover, there are sources of incredible heat. The thing is that, in particular areas, the crust both under East Antarctica and West Antarctica isn't thick enough to protect ice sheets from the heat of the magma, which is bubbling below the surface. No one knows why the underground heat is especially intense in such hotspots, but it's a fact that this heat can lead to the warming of the ocean and melting of ice. By the way, a 25-year-long survey has also shown that nowadays, Antarctica's ice is disappearing at an alarming speed. During more than 2 decades, the continent has lost a whopping 3 trillion tons of ice. Approximately 1/3 of this ice vanished in July 2017, when a monstrosity of an iceberg with an area of 2,000 square miles broke off from the Larsen C ice shelf. It weighed more than 1 trillion tons and was the most massive iceberg ever recorded. The rest of the ice has been steadily melting and flowing into the ocean, and this process has been accelerating over the past several years. In any case, not all the mysteries of Antarctica have been solved yet. For example, scientists still can't explain the origin of high-energy particles literally streaming from the continent's ice. These particles keep shooting up from the ground and head away into open space. However, there's a theory that could probably explain this phenomenon. Some researchers are sure that the particles are cosmic rays that come from space, blast through our planet, and come out from the other side. Now, this idea has one serious drawback. The cosmic particles people know about shouldn't be able to pass through Earth without crashing into something and disintegrating. That's why the unusual behavior of Antarctica's particles has remained unexplained so far.